So, welcome everybody, and thank you for coming to this talk. My name is Roberto, and I'm a software engineer in the ARM demo team. Today I will share the talk with Carl. We know very well Carl as a global leader of evangelism in Unity. We will talk today about the same topic, mobile VR, but we will do it from different perspectives. I will talk from the perspective of developers. I will go first through our Ice Cave demo and the ARM guide for Unity developers. And after that, I will talk about our experience in porting our latest demo, Ice Cave, to VR, to Samsung Gear VR. Finally, Carl will talk from the perspective of the platform, which is used by more than half of game developers all over the world. We all know that VR is getting great momentum. Unity is aware of that. And the VR native integration has been one of the latest achievements of Unity. Carl will talk about the VR integration into Unity and the best practices to get the most out of Unity when developing mobile VR applications and games. So I will start by showing you a short video about our latest demo, Ice Cave. This demo was was developed in collaboration with Real Time UK, the company that supplied most of the assets. And we developed a number of highly optimized effects for this demo.
An abandoned cave, home to an ancient lunar calendar, used at one point in time as a site for celebration. In the distant past, people would climb the mountain up to the glacier cave, and after paying their respects, rotate the statues of the zodiac animals around the calendar board. No one has visited the cave for thousands of years, but the spirit of the past is still alive.
So I hope you enjoyed the video. There are some other special effects there in the demo which are not mentioned, but you will be able to find a detailed description of all the effects in the demo and the source code also in the latest release of the ARM guide for Unity developers. We released the third version just a couple of days ago, especially for Unite Boston, and you can download for free the ARM guide for Unity developers at Mali developer website. So now that we are more familiar with the demo, I would like to talk about our experience in porting this demo to Samsung Gear VR. All the work, mostly of the work, was performed by the student Kapil Samusandar, that was working during his summer placement in our team for 8 weeks. I have to say that he had no previous Unity experience at all. So all the work I will show you was performed by this student. By the time when we decided to go for a VR version of our demo, it was available 2 options. There were 2 options. The plugin approach, which uses the Oculus Mobile SDK, and the just released native VR in Unity. As the plugin approach has some logical limitations, we decided to go for the VR native integration in Unity, despite the fact that it was just released at that time and there were a number of issues unsolved. So we decided to go for the Unity native support for porting our demo to Samsung Gear VR. Just a few words about Samsung Gear VR headset. I think most of you have seen in several booths here at Unity Boston. Just to mention that there are a couple of models for Note 4 and S6. There is an interesting feature, which is the manual focal adjustment, which is very useful for people wearing glasses. And the Oculus asynchronous time warp technology, which is there, is really important to have the best performance. Getting a nice performance is very important to have the best user experience in VR, as you know. So in principle, we decided to go for the native approach. And what you need to do is to get your device ID, go to the Samsung, to the Oculus website to get the signature file, place it in that path, check the virtual reality supported option, and build your application. It's as simple as that. So we followed all this step, and we got that. Nothing was working. Yeah, in principle, it's not that simple. It's never that simple. The problem was that in the original demo, we were setting custom resolution, and as you know, it is not possible, not so far. We also didn't know about the developer mode. As you know, it is possible, now I know that, it is possible to set in the Samsung device the developer mode that allow you to run your application in VR mode without inserting it into the headset. And this, of course, saves you time when you are developing and debugging your application. So one of the first things we had to do was to remove the user interface, or the original user interface of the demo, because it was not suitable at all for VR. And instead of that, we just added a very simple user interaction with the touchpad, which is coming with the Gear VR. And the original application, the original demo also had an animation mode. And the first time the people started to use the VR, or once we got that working, so user experience and motion sickness with the camera in the camera animation mode. So we removed that, and we carefully set the speed of the camera, because even when the camera moves just a little too fast, many users experienced the motion sickness. So we spent some time setting the right speed to get a speed which people were more comfortable with. We were looking from the point of view that the ice cave is really big, and the user doesn't experience any claustrophobic sense when moving in the cave. So the user actually can explore different parts of the cave and enjoy the different effects that take place there. We couldn't, one of the effects in the original demo, the dirty lens effect, we had to remove it because dirty lens effect, as we implemented it, that was with a texture quad rendered on top of the scene, and with a variable intensity depending upon the alignment of the camera with the sun. It doesn't look right in VR. It's something weird. So all that the user recommended to remove it, and yeah, we did that. Also in the original demo, the user could go through the geometry to get a view outside of the cave, but in VR it didn't work. Going through the geometry in VR just break all the VR experience. So we implemented the camera collision and very smooth sliding when the camera goes very near to the wall of the cave. And we developed specially for the VR version a couple of extra features. One of them was to stream from the device which is inserted in the Gear VR, the camera position and orientation to a second device in such a way that the people could see what the user is actually seeing in the headset. If you come to our booth, you can see that working. Yeah, the student implemented that. It was not difficult because the new interface for TCP in Unity is very high level, and it's really easy to implement a server and transmit data through it. Another feature we added was to implement an alternative user interaction by means of the mini Bluetooth controller. By the way, at the end of the talk, a lady will be there collecting the form, the feedback form, and it will give you this Bluetooth mini controller. So we use that and this Bluetooth mini controller by implementing a plugin to Unity. It is also working in our booth. So this was mainly all the changes we need to do to our original demo. And now I would like to go through really quickly through a new rendering technique we developed in our team for rendering shadows. It is based on local cube maps, and it is very effective, and we think it is really good, works really good for mobile devices, where rendering shadows is really stress your GPU, and for VR is really a performance killer. So this technique works in two stages. During the first stage, when you're rendering your cube map, you render the transparency of the scene in the alpha channel. So in such a way that we can use that cube map, for example, for reflections, the RGB channels when rendering the scene, and we can use the alpha channel to render the transparency of the scene in such a way that when the geometry is completely opaque, we write in the alpha channel 1. When the geometry is transparent or there is no geometry, we write in the alpha channel 0, and any other intermediate value for semi-transparent geometry. What we get in the alpha channel is a map where the light can come through and reach our scene. The only condition is that the light should be outside of the proxy geometry we use to delimit where the cube map is valid. At this point, we use no information about the light position and no information about the number of light. So this technique is independent of the light position and is independent of the number of light. The only condition is that the light should be outside of our proxy volume. So let's see what we need to do at runtime to render our shadows. So at runtime, we build in our vertex shader a vector from the vertex to the light position, and we pass to the fragment shader this vector as a varying. in such a way that this vector is interpolated, and in the fragment shader we get the fragment to light position vector. But before fetching the texture from the cube map, we need to apply the local correction to this vector, as you know. So for that, we need to find the intersection of that vector with our proxy geometry. We find that intersection point, and we build a new vector from the position of the cube map to that intersection point. And then we use that vector to fetch the texture from the cube map. We are interested in the alpha channel value. If we, when retrieving the alpha channel value, we read there 1, it means that in the direction of that vector, in the fragment to light vector, there is an opaque geometry. So the light can't reach that pixel, and that pixel will be in shadows. If when we read the alpha value, we get 0, it means that in the direction of the fragment to light vector, there will be a completely transparent geometry or no geometry. So the light can reach the pixel, and that pixel will be completely lit. So this is the way. This is really simple. There is a little more detail, but you can find the whole information about this technique in the ARM guide for Unity developer. An important feature of the shadows is the softness. As you know, the shadows are softer the farther away are from the object. And this technique can reproduce that fact very easy. How we do that? So instead of fetching the texture from the 0 level min map of the cube map, when we are baking the cube map, we also build all the min maps of the cube map. And we interpolate between cube maps level min maps in such a way that we use for that a value which is proportional to the distance from the fragment to the intersection point. So instead of using the function textcube, we use textcube LOD. As you know, in the second argument of that function, you need to pass in the fourth component that value that you want to use for the cube map interpolation, for the min map interpolation. And this is what you got. What you get is an example. This small technical demo, you can play with it in our booth. The left slider changed the light position. The right slider changed the value we actually pass for interpolating the min map levels. When it is in the lower position, we are passing 0. So it means we are getting we are reading the texture from the 0 level min map, and the shadows is really hard. As soon as we start to make this value greater, so the shadows become more and more soft. So let's wrap up what we've seen up to now. For any detail, any extra information you think you need, please check out the ARM guide for Unity developers. I think that Unity has made a great contribution to the VR democratization by releasing the native integration into Unity. VR is now, we need to consider VR also that is a great boost for mobile games. Mainly because right now with VR in mobile, the user experience is no longer limited for in gaming to the small screen of our devices. Now the user can feel inside of the whole game, can experience really a VR experience, can experiment a real VR experience. And with this porting, we also wanted to show that it's possible to achieve a high quality VR also in mobile. And now I hand over to Carl, and I'm sure you will enjoy his talk. Thank you.
Gracias. Hello.
Okay.
Hello. Is the mic working? Okay. So I'm going to give a quick overview, a follow-up on the technical side. And the benefit of listening to this presentation, my part, is on the end he will better understand what he can do from the design viewpoint from your game. For VR, of course. But on the end, I have also a very special request. And help me remind, I forget things. Okay. So I'm Karel Kallewart. I work at Unity Technology as an evangelist. But I'm actually super excited always about VR and AR. A long time ago, I studied VR and AR in school. And then I actually made my first applications for people who were afraid of spiders. That's where I started from, making VR and AR applications and helping patients for that. And then I sold the company, and that's it. So I'm going to quickly talk a bit about Unity 5.1 and how the integration works with Unity. Some technical advice, but mainly about the design advice. And the VR setup in Unity 5 is pretty awesome because, hey, as you saw during the keynote, you just click a button and it's done. You can take your old games that you made before, not VR or AR, you click on it and you can bring it to that. Super powerful, and I want to thank our partners to work with them to always integrate that natively. Of course, on the back end, we do a lot of optimization performance. One of those things is sharing the shadow between the left eye and the right eye, so you don't calculate 2 times, your draw calls don't go crazy anymore. Things like that we work on. But also like culling. If you do culling, the 2 different cullings you have, you can share them between the left eye and the right eye. You don't have to do it, just click the button, it's all done for you. That's the beauty of Unity, taking the hard work out of it. And the last thing you have to press is press the play button, and you're done. You don't have to complain. Also, there's a lot of new APIs. The API, like for the distance between your left eye and your right eye, you can optimize that, because if you have a slight difference between the left eye and the right eye, your CPU and your brain starts to fry a little bit after 20 minutes. But also a mirror API. If you still want to see the left eye and the right eye in the editor, you can see them both. On technical advice, I think the one thing you have to remember is don't drop frames. The moment you drop frames is when you become motion sickness. That is the one thing. Hey, if you turn left or turn right or looked up and you have frames you drop, that's when you become sick. Okay. There's a lot of different quality settings that we can do, and that's the beauty, because thanks to the native integration, you can develop for multi-platform, and then you can use different quality settings, and you have one build. You don't have to have like one level with one asset store package integrated and another asset store packages. It's all one. Okay. If you don't want to drop frames, one of the things that you can do is, of course, more a cartoon style. Okay. And that was a nice example here. Who has played the game Job Simulator? Okay, it's time to play more games. Only a few people play here. Okay. But the quality settings should be set automatically when you click on VR. If it's not, I take a picture and you can use those quality settings. Okay? The main thing I would advise you is profiler, 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 profiler. If you never use the profiler, shame on you. Use it. There's a lot of don'ts and don't do it. The main advice I would say to you is think about the polygon count. And also, what do you do? More polygons or more texture? Try to find the right balance in there. Okay. Because more textures also add to the memory, especially when you're going to go to a mobile device for VR, then you have to think about that. Okay. So, but if you have a PC, I would say, well, boost up everything you can. But if the moment you have a mobile device, you have to also watch out for your CPU speak, because that can drop a frame rate. Yeah. But no, my favorite part is the design advice. I'm not going to go into all the input devices that exist and what's possible. But one question you have to ask yourself, will you use an input device? Is it really necessary to use an input device? Because when I put on the Oculus and I have to use a keyboard, it's hard. I have to try to find even my keyboard. Okay? Especially when you have everything around your desk, it becomes cluttered and you have to try to find it. We all know the gaze menu, try to use things like that. And this nice the Oculus Touch, a phenomenal device coming on the market. That's everybody was looking for, I think. But we use a Bluetooth? I don't know. It's really difficult sometimes. Currently, from a design viewpoint, think about maybe 5 or 20 minutes experiences. We don't have yet the optimal experience, like say, for 10 hours or 5 hours to play a game. And for your eyes, it's still hard. The resolution sometimes is not there yet. The distance between the different eyes is not correct yet. So it makes it hard on the brain. But we also have Rob Pardo. I think most of you have heard about Rob Pardo. He made an indie game called World of Warcraft. But he gave a great advice. And one of those great advices, and so it really came from the mobile part. I think in the beginning, when most of you started to play mobile games, we had those fake joysticks. It didn't work. Why? We took the old game, we ported it directly over, we put face joysticks on it, and it doesn't work. It's exactly the same right now. What we do is take old inputs and we bring them directly to the VR world, and it's not working. So try to really design that. Okay. Also, to Gear VR, there's no cables. What happens? The player will look behind them, not always in front. A nice example is Temple Run. Temple Run, what they did, it was a third-person game. They brought it to the market in first person. Okay. You can look behind and you see the monster. But what the design was changed there What I really like is the shadow in the front. You still have the experience of the monster running behind you. You don't see it. So that's correctly porting over a game that was third person to first person on mobile. I'm going to quickly go here. One thing is that make sure when you make a game, the Unity at the moment has a logo when you start up and you use the free version. It is not stereoscopic, so remove it. Because if it's not stereoscopic, the logo, your app is refused from the stores. UI, when you put it, I have 1 minute. Okay. Let me go fast then. We have, I have 5 minutes. Okay. Okay. So we have the UI design. Keep it between 2 and 3 meters if you can, because that gives you more depth perception. If you go too far, it doesn't get it. Your eye is very important. I'm going to talk to your eye a little bit later. Make sure that the UI fits in the viewport. What we see sometimes, they put the buttons very close, but then it doesn't fit. I have to read from left to right or from right to left. You don't have a great experiences. When you go to a menu where you have lots of buttons, make sure you can still orbit the camera. Because if you pause your game or go to a menu and you put the camera to locked, and you move around with your head, you become dizzy. Okay? Nice advice from Oculus we got also is fade to black. When you change from scenes, like the game starts up, you have your menu, then you go to your gameplay. Well, fade to black, or when you change from scene or change from a viewpoint in the game, don't switch in 1 second, because it's really difficult for the body to understand the motion. Okay? So also, what I'm going to do, I'm not going to read this, but I'm going to go to the images right away. Okay, who has played this game? Okay, we have one player in the audiences. Okay, besides games, you should play games too. Okay. So one of the great things about this game is that the integration of like the health buttons are really good done. You can see here 75. It's not like a button. No, it's a real 3D object like in real life. The same as with this game too. The timer and how much time you have to play in the game is really integrated in the design. It also adds to the perspective, more integrated in the scene. Okay? I think everybody knows this image. You can say yes or no. Okay. What's so important about this image? It's the same as VR problems. And that's the advice I give you. VR, you need also artists. You need a 3D aspect. And the painter of light really created these shapes. You feel it's 3D. Why? Because the light is very good, correctly done. Okay. When we go back, incorrect perspective. Okay. You would think what has to do with VR because it's all perfect. Well, no. It took them a while to understand perspective. Right? Actually, this is earlier than the other ones, but the perspective is here correctly done. Why? Clues of perspective. I encourage you to take a course in the eye. Take a course on the eye from the beginning to 14-year-old eye. That's where you have to understand the process, how eye is looking at 3D objects. It takes about 14 years to develop an eye that can correctly see 3D. Kids at 7 don't see perfect 3D yet. And it's all because in the beginning you see very fast 3D because you get clues. That person, we know the height, we know the size. You use clues in your game so they better can adapt right away to the 3D aspect. Okay. We also talked about buttons in Unity. We have the flat buttons. The great thing is in Unity, you can change the buttons in one shot to world screens buttons. So in one shot you can change that to convert your game. Avoid bright images or flicking of images. Not everybody likes that. Epilepsy is a huge problem of that. When you have a crosshair in the screen, when you look at it, change the depth of the crosshair also, because that gives you a clue of the depth of your scene right away, perspective. Or use a trail when you see the motion, so you get less motion sickness. Okay. Taking an elevator in a video game is difficult to understand that. Okay. And recently I was in an experience where they vibrate the floor to give you the sense of going up and down. Watch out for that. But a nice example, I think, is Titans of Space. Who has played this game? It's not a game, it's an experience. Who has it? Okay, we have 4 people in Boston who play games. What they did to make sure you don't get dizzy is they give you a fake body, so you understand it, because you're turning and left and right. And I would say, play the game. It's really nice. And my daughter of 7 years old played it, and she was convinced I went to space, Dad. That was for her the true story. Okay. Don't forget that people look in all the directions in a game in VR. Temperament was a nice example I told you about. tons of space. You look around and make sure the spaceship was there. Okay. Well, one advice I want to do you for the artist here, don't scale the left eye versus the right eye. We've seen that. I need to do artistic experiences, but that creates you really nauseated. And what I mean is a full scene design versus empty scene. And that's with this. Most of the design is done in an editor of the levels. What they do is they put it on quickly, okay, and then they work in the editor and they build everything up there. Okay. What happens is the screen looks cluttered and they think the scene is full, I have to stop at it. That is not how it works. It's the same as an architect who looks at the blueprint. When you look in real, it looks totally different. So study environments, study how like the little things become real in an environment. It's not how it looks on the screen cluttered. That's I want to give you the big advice on. No, first person is not always to go, and it's really difficult sometimes. A third-person game like a tower defense works really great in VR because you're controlling from top other characters. I'm controlling you. A nice example is Off-Road, the game. Who has played this game in the past? Okay, it became to VR, and then you can control with your head the direction of the car. There are some really awesome third-person games now also that use the motion of your head to turn left and turn right and walk forward and stop. Check those out. Okay, but mainly I want to thank you to be here, and I hope you got some advice how you can use this. But before we continue, before we go to Q&A, I also want to point out we're very lucky. Our HR is here, so if you're looking for a job, you're the most lucky people in the world. Okay, and also let's take a picture of everybody here. Okay, but let's be everybody happy. Okay, like, yes, then I can send to my boss. Look, man, I did the best job ever again. Okay. What? Now, thank you, and Roberto and I will be here for questions. And don't forget to fill in the question, the survey.
For any question, I will be there at the art booth. Please come to our booth.